Hello all. In this video I shall demonstrate the functioning of L293 motor drive IC through PROTEUS simulation. This PROTEUS is a commercial software which is expensive, but you can get a demo version with some limitations. You can download a demo version of PROTEUS 8 software for free. It is a great one for circuit design analysis. Download this demo version of PROTEUS and install it. Fire up PROTEUS. This is the welcome window of PROTEUS software. Click on new project. As it is a demo software, we cannot save the project, so just click on next. Select the create a schematic from the selected template. That is a default template. Select next. We do not create a PCB layout for this, so just skip this and check this no firmware project. As we are not going to use any microcontroller for this demo, select this no firmware project, click on next and then finish. Now the editing window opens. The big window is the editing window. On the left hand side top small window is the overview window. And this is the object selector window. On the left hand side you can see some icons, which is the toolbar. Click on component mode. This is the second icon from top. This is the component mode, and then click on this letter P to pick the devices. Click on P, so the pick device window will open. We need L293 IC and a motor for this demo, so type in L293. Double click it to add it to the device list, and then type in motor. And select this simple DC motor model. Double click it, so that will be added to the device list. You can see one L293 is added and a motor is added. And to test the motor through L293 IC, we need logic state. That is, we have to change the logic, accordingly the motor will change the direction. So type in logic state. Select this logic state, double click it. Now that is added to the devices. Now close the pick devices window. Select L293 and move the cursor onto the big window. The cursor will change to a pen mark. Again click the mouse. The device will be placed, that is L293 will be placed. Now click on motor, place the motor here. This L293 is a dual motor control, so you can place another motor. Move the cursor to the motor stop pin, just click on that and then draw a line so that it is connected to the pin 3 of IC. Same way connect the bottom of the motor to pin 6. We can now zoom it. Just click on zoom to area and then select the area to zoom. We will add the logic state. Click on logic state. Place one here, place the second one and a third one. The third one is the enable pin. Connect it to pin 1. First two are the input pins. So this is the logic state pins. According to this logic selected, the motor will rotate either clockwise or anti-clockwise. Now we shall add the power source to the IC. Pin 16 is the VCC. Pin 16 is the VCC and it is the power source for L293 IC. At the left hand side you can see the terminals mode icon. Click on this terminals mode icon. You can see power, ground, bus, input and output selections. Click on power and move the cursor near pin 16. Click here to place a power source here. Again at pin 8 you need a power. So pin 16 is the VCC, that is 5 volt. So right click on this and edit properties. Under string you enter VCC. Click OK. And this is the power source for motor. Pin 8 is the power source for motor, that is usually 12 volt. Right click, edit properties, and then under string enter plus 12 volt. Remember to add plus. That is a power source for the motors. And we have to add the ground. Select ground, place the ground here. So this both pins of the IC should be connected to ground. Now ground is connected. Now the schematic is ready for simulation. At the left hand side bottom you can see a play button. Just click on that play button to start simulation. Make the third logic state high so that the enable pin goes high. The motor will start run only if one pin is high and the other pin is low. So make the first one 0 and the second one 1. Now the motor starts rotating counterclockwise. If you make the third logic state disabled, that is 0, then the motor will stop. Now you make the first logic pin 1 and the second one 0. The motor starts rotating clockwise. So a 0 and 0 at the input will make a 1 and 1 at the output and the motor will stop. And if the output is 1 and 0, the motor will start rotating. So this L293 IC has 2 inverters per motor inside the IC. If you give 1 at a logic state input, it will become 0 at the output, and if you give 0 at the input, it will become 1 at the output. The enable pin can be supplied with a PWM signal from microcontroller, and the speed of the motor can be varied. According to the pulse width modulation signal given to the enable pin, the speed of the motor can be varied. As the L293 IC is a dual motor control IC, we shall add the second motor also. Just stop the simulation first. Connect pin 11 to the second motor top, pin 14 to this second one, the lowest part of the motor. We have to add the 3 logic states for the second motor. For debugging purpose, we can add a probe mode. At the left hand side you can see a probe type icon. You click that probe, you get voltage and current probes. We will select voltage probe click on this point to add a voltage probe here. Again click on the bottom of the motor to add another voltage probe here. And another debugging tool is instruments. You can see an instrument like icon at the icon to the bottom of the probe. Click that, you get different instruments: oscilloscope, counter, logic analyzer. We'll select the DC voltmeter and place the DC voltmeter here to the second motor. Connect the DC voltmeter. Now we shall start the simulation. We'll enable the first motor. The first motor logic is 1 and 0, so the motor starts rotating clockwise. If you see the voltage at the logic probe level, the top of the motor is at 11.14 volt and the bottom of the motor is 0.85 volt. So there is a voltage difference and the motor rotates clockwise. If you want to stop the motor, you just click on this logic 1. So both the points will become 12 volt. So there is no potential difference at the points, so the motor will stop. If you make the first logic as 0, the motor will start rotating anti-clockwise. You can see the voltage probe levels. The bottom one has changed to 11.14 volt. The top one has changed to 0.85 volt. Same way we can start the second motor also. Click on enable at the second motor. So you can see the second motor also running, and you can see the voltage across the motor as 10.3 volt. If you change the logic, it will start running anti-clockwise, and you can see the voltage level has changed to minus 10.3 volt. If you disable it, the motor will stop. The voltage will show 0 volts. Now both the motors are running and you can see the voltage levels. Thank you for watching.